Okay, so on number 39 it says, identify the transformation, sketch the function, draw and label the asymptotes, vertical, horizontal, and state the domain and range. So, one thing you have to keep in mind is that exponential functions are the ones that look like this, and log functions are the ones that look like this. Now, when you graph it in a calculator, you might only see this, but you have to remember that it actually does have that part going down towards the vertical asymptote, okay? So when you type in ln of x plus 6 and then minus 5 into your calculator, so we go to y equals, type in ln of x plus 6. And don't forget to close parentheses on these because ln does not automatically close it for you. And then minus 5. Well, I'm going to go to my table set and make sure it's on auto. And then go to my table. Well, what I see, and what I know about transformations is that I'm going to go to the left 6 and down 5. So I'm going to go ahead and go up to negative 6. And I notice that negative 6 is my first error message, right? That means that's where the vertical asymptote is. So when I go over here to negative 6, I'm going to draw a vertical dotted line. That's my vertical asymptote. Okay? And I kind of did that quickly, but if you don't know where ln is, remember, if you know log, then it's ln. But a lot of times we don't use that log, we use the alpha window. So if you ever have to, alpha window, number 5 is log base. And that's how you type in the log with a different base, okay? Okay, so I'm going to go back to my table. So I see that at negative 5, it's at negative 5. So I'm going to go negative 5, negative 5. At negative 4, it's at negative 4.3 something, so that's negative 4.5, so negative 4.3. Negative 3.9 at negative 3. And then let's skip a few and go to negative 1. Is negative 3.39, which is basically negative 3.4. Let's add 0, you're at basically, or at 1, you're basically at negative 3. And that's enough. We're just going to go like that. I know that's what it looks like over there. But what you have to remember is that it actually does do this right here. Right there. Now, if you look at the graph, I'm going to go negative 8 to 8, negative 8 to 8 on my window. Negative 8 to 8, negative 8 to 8. But look at my graph. Here's what I see. Okay, so you actually do see it going down a little bit, and that's good. So that's, you remember to sketch that, okay? But if you look at the points, the first point you'll see is that one. Okay, so the only thing was, this is a vertical asymptote because it goes up and down vertical, and then domain and range. So remember, domain is left and right. The farthest to the left it goes is negative 6, but it doesn't actually reach it, so we put a parenthesis, and then it goes all the way to infinity. Range is up and down, it goes all the way down, and it goes all the way up. So all real numbers. Okay, so now let's graph the exponential function number 40. Okay, so first I'm going to type that in, 10 times 1/2 to the x plus 2. 10 times 1/2 raised to the x, and then plus 2. So to me that looks like a vertical stretch by a factor of 2. We're going up 2. When I look at this exponential function, that's what I should see. And it's actually, I'm going to go on this window, negative 3 to 10. So in my window for x, I'm going to go negative 3 to 10. And then the window for y, it goes from 0 to 45. So I'm going to go 0, 45. Okay? So if I look at my graph, then here's what my graph on my paper should look like, okay? Notice how this levels out above the x-axis. That's because this plus 2 shifted up 2. So when I look at this table, at negative 5, I can't even see, okay, on my graph. So let's graph what we can see. I see that at negative 2, it's at 42, yeah? So at negative 2, we're at 42. That's 40, so 42 and a half, so 42. It's right around there. At negative 1, we're at 22. At 0, we're at 12. 2's going on here. At 1, we're at 7. And then at 2, we're at 4.5. 3.25. So if you think about it as 1, 2, 3, 4. So here is 1, 2, 3.25, so it's right around there. And then it's going to get closer and closer. I don't know if you can tell, but it's getting closer and closer to 2. So it's leveling off to 2. So if this is 2, and that's my horizontal asymptote, kind of went higher, right there. And so I'm going to draw my points. Getting closer and closer to 2. Try to go through the points. Don't go past 2. Don't go back up. And there you go. So, domain is left and right, all real numbers. But range, the lowest it goes is 2. Doesn't actually reach it, and it goes all the way up to infinity. Okay, I will be looking for specific points graphs, so don't just kind of draw a sketch. I have exactly that. Okay. For these problems right now, we need to talk about your different formulas that you need to know. Okay. You've got amount equals principal times 1 plus or minus the interest rate to the t. Plus is if you're going up in value, negative if you're going down in value, okay? You got, this is annual. Everything is like per year or per month, or it's, I shouldn't say per month on that one, but per year. I would just go with that. And then k times a year. Okay, this is when you're compounding, you invest money and it's compounding k times a year. Annually is once. Semi-annually means 2 times a year. Quarterly means 4 times a year. Monthly means 12 times a year. Weekly, 52. Daily, 365. So this is principal times 1 plus r over k to the k t. This is specifically investing money k times a year. Now this is when it's continuously. Compounding continuously. Okay? So you got these 3 formulas. 1, 2, and 3. So on number 41, when it says money invested at $5,000 interest rate, and it says compounding annually, that means I'm going to use formula 1. Write a function to represent the worth of the account at any time t, meaning that needs to be there. Interest rate is a positive number, so we're going to go A equals principal, which is $5,000, the initial amount, times 1 plus, because we're gaining money, 6.72% interest. 6.72% of the decimal 2 places, 0.0672 to the t. That's the formula for any time t. How many years will it take for the account to quadruple? Well, quadruple means times 4, okay? So how many years will it take for this account to equal $20,000, which is quadruple the initial amount, $5,000. So if I want to solve that, you can either solve it like a logarithm, or you can graph. Put this in y1, put this in y2. Let's think about window for a second. X represents time. I don't care about 0 time, and I don't think it's going to take 50 years. I might go 25 years just to be safe. Maybe I need more, maybe I need less. On Y represents money. I don't care about negative money, so I'm going to go 0. I need to see 20,000, so I'm probably going to go 30,000, just to go a good safe amount above. So in Y1, I'm going to go 20,000. And Y2, 5,000 times 1 plus 0.0672, close parentheses raised to the x in place of t. Window, like I said, 0 to 25, 0 to 30,000. And graph. So there's my 20,000, and here's my other function. Okay. So what I want to do is I want to solve for the time, which is an x value, for when these two functions equal each other. So I go second, calculate, number 5, and just enter, enter, enter. And you see that these two functions equal each other when x equals 21.3. So that means, so second, calc, number 5, enter 3 times. Okay, and you get 21.3 years. And that's your answer. Okay? If you want to solve it like a log, I can show you right quick. 20,000 equals 5,000 times 1.0672 to the x, or to the t, doesn't really matter. First thing you want to do is to divide by that 5,000 to get rid of the term that's being raised to the power. So if you divide by 5,000, let's say 50,000. You get 20,000 divided by 5,000, that's 4, equals 1.0672 to the x, or t, whatever. Change it to a t again. Now put it in log form. Log base, remember the base of the exponent is base of the log, 1.0672 of 4 equals t, and now you solved for time. If I type that in, just go to my home screen, and I type in alpha window number 5, log base 1.0672 of 4, and I get 21.3 years. Okay? So whichever one makes better sense to you. 4. Okay. So on 42. 42 is kind of a long one, so let's go through it. Principal is 20,000. If the money given is invested into an account that compounds semi-annually at 5.7% interest, what would the equation be for the amount of money in the account? Semi-annually is k times a year, which is formula 2. So amount equals principal times 1 plus r over k to the kt. Okay, so let's figure out what we need to fill in. It says, what would the equation be for the amount of money, meaning I need to leave this as a time value. A equals, what's the principal? The principal is 20,000. 1 plus my interest rate is 5.7, so I'm put 0.057 over k. K equals 2. What is that noise? Whatever. K equals 2, so I put 2 here and 2 there, and then t. And that is my formula for the amount of money at any time t. Now, how much money is in the account after 20 years? All I do is replace t with 20, and I'm good. So all I gotta do is type that in. So 20,000 times 1 plus 0.057 divided by 2 raised to the 2 times 20 is 40, and I get it. The answer is $61,546, and we'll just go with closest dollar. Okay? If the money given is invested into an account that compounds continuously, well, continuously is the weird one, it's the PERT. Okay? So amount equals principal times e to the RT. Okay? So amount equals principal, same amount of money, 20,000, times e to the 0.056r times t. So leave that as t. Again, 20 years, so amount equals 20,000 e to the 0.056 times 20. 20,000 times e, which is second if you write above the ln beside the 4. That's right there. It's also right here if you want to raise it to the power right there. Doesn't matter. E to the 0.056. Notice how they were different interest rates. You got to be careful about that. Times 20. And you get $61,297. Okay. I don't know what I just did there. $297. Okay. So when it says which account is better for the first 20 years, well, compare the amount of money, and whichever one's bigger, that's the better account. So, compounding semi-annually at 5.7% is better because it's 546 versus 297. Okay. Let's talk about 43. 43 is solving an exponential equation. And we did a homework over this. We did not take a test over these questions, but that's okay. We can still go over it. If it's in exponential form, one of the easiest ways to solve it is to convert to a log. Okay? It doesn't have to be done that way, but it's probably the easiest way to remember it. Log, remember the base of the exponent is the base of the log, 16 of, can't be negative 3n, so 1 over 64 equals a negative 3n. How do I solve for n? Divide by negative 3. And then let's type that in. The light is just really annoying me. Okay. I'm going to go out for window number 5. 16 of 1 divided by 64. I'm going to divide that by negative 3. And I'm left with 0.5. So n equals 0.5. Okay, now let's go to 44. It's also an exponential expression, but I need to get rid of this 3 before I can convert to a log. So I've got minus 3 minus 3. 10 to the a equals 84. And let's convert to a log. Log base 10, base of the exponent, can't be a, so it's got to be 84 equals a. So all I got to do is type that in. Now for window number 5, log base 10 of 84, and that is a equals 1.924, and let's get 3 decimals on that. Okay. On this one, 9 to the 6v, very similar to this one. Log base 9 of 45 equals 6v, divide by 6. And I've got log base 9. No, I don't know, I'm typing it again. Writing it again, I'm just going to type it in. For window number 5, log base 9 of 45, and then divided by 6. 0.289. I will say this one right here, on number 43, just to go back to that for a second. The only reason I said that you didn't have to do it that way is because 16 and 64 share bases in that either 4s or 2s. If you look at 2s, 16 is 2 to the 4th and 64 is 2 to the 6th. If you look at 4s, 16 is 4 squared and 64 is 4 cubed. Let's go ahead and go with 4s. So it's the same thing as saying 4 squared to the negative 3n. And this is the same thing as saying 4 cubed in the denominator, which means 4 to the negative 3. Well, the 4 to this equals 4 to that. The 4's already equal each other, so it's just a matter of negative 6n equals a negative 3 if you divide by negative 6. And then n equals 1/2. Same thing as 0.5. So it's just a matter of how you want to work it. Okay. In the same way that log base 7 of 7 to the 4th equals 4, because they cancel each other out, log base e of e to the 4th also equals 4. Okay? So the thing to remember, though, is that log base e is ln. So when you see ln of e, they just cancel each other out. So what makes that easy, or what makes that nice, is that when you have an e right here, if you get it alone, then you can just take the natural log of both sides and it'll cancel out. So first I need to add the 7 to get it on the other side. E to the negative 7m equals 99. And what you can do is just take the natural log of both sides. So natural log of 99, those cancel out. Negative 7m equals the natural log of 99. And then just divide by negative 7. And you've got it. So natural log of 99, remember natural log is by the 4. So natural log of 99. Close your parentheses on this, it doesn't do it for you. Divided by negative 7. and you get negative 0.656. Okay. Let's go with 47. 47 says simplify. All we need to do is combine like terms. Real with real, imaginary with imaginary. Negative 7 and negative 4 is negative 11. That's a plus sign. Negative 5i and negative 6i is negative 11i, and I'm done. Okay? All I was going to do is add like terms. Okay, now we're multiplying. Negative 4 times 2 is a negative 8. Negative 4 times 6i is a negative 24i. 2i times 2 is 4i. 2i times 6i is 12i squared. But remember, if I is the square root of negative 1, then I squared is just negative 1, because you square the square root and it goes away. If you're not sure, type in 12 I squared. I is above the decimal. And then square it. And it'll tell you negative 12. Okay? So then that's just minus 12. Negative 8 and negative 12 is a negative 20. Negative 24 and positive 4 is also a negative 20, but a negative 20i. Okay? Okay. Now, when you have division by imaginary numbers, you can't have an imaginary number in the denominator. So in this case, all we gotta do is multiply by I on top and bottom. Okay. So it might actually be easier to think about as multiplying by negative I, but we'll just go ahead and go with this. I've got 4i. I've got 5i squared. And I've got I squared. Okay. So here's what I've got. This right here is 5 times negative 1, which is negative 5. I'm going to write that first because it's real. Plus 4i divided by I squared, which is in fact negative 1. But if you divide by negative 1, that's really just negative 5 divided by negative 1 is positive 5. And then 4i divided by negative 1 is negative 4i. Or think about floating the negative to the top, distributing, and then you divide by 1, it doesn't matter. So there's my answer. On 50, just like with the square roots, we don't have like imaginary numbers on the bottom, but what I was getting at is that you want to multiply by the conjugate of the denominator, which means negative 2 minus 4i. Okay, so we multiply the top. I've got 12, 24i, minus 10i, and minus 20i squared. Remember, I squared is negative 1, which makes that positive 20. Okay, so 12 plus 20 is 32. 24 minus 10 is 12. 14, just kidding. So it's 14i over. Denominator, negative 2 times negative 2 is positive 4. That's a positive 8i. Negative 2 times negative 4i, positive. 4i times negative 2 is negative 8i. Let's cancel out. Negative 4i times positive 4i is negative 16i squared. That makes it a positive 16. That's a 20. All three of these numbers are even, which means you can divide all of them by 2. So 16 plus 7i divided by 10. Here's your final answer. Okay? Now, the only reason this is typed like that is because it wouldn't let me just type in plus and minus. So that really is just that. Okay? So last two problems. Solve with the quadratic formula. Remember, A is the number in front of the first term, B is the negative 4, and C is the 8. So, x equals opposite B, positive 4, plus or minus the square root of B squared. So negative 4 squared, minus 4 times A times C, 1 and 8, all over 2 times A. 4 squared is 16, but I do suggest you just type that in. 16 minus 32 is negative 16, but just to be safe, I suggest you guys just go. I didn't mean to do that. So negative 4 squared minus 4 times 8, and you should get a negative 16. So 4 plus or minus the square root of negative 16 all over 2. Remember that when you're taking the square root of a negative number, it's imaginary. It's got an I, and the square root of 16 is 4, so 4 plus or minus 4i all over 2. Divide each of these by 2. 2 plus or minus 2i. Okay. And this one? I said x, it's really n, but well, whatever. So b is this, might as well be x. Doesn't really matter. X equals opposite b, negative 12. Plus or minus the square root of b squared. Minus 4 times a times c. All over 2 times a. So 12 squared is 144. Minus 4 times 1 times 46. It's negative 40. So negative 12 plus or minus the square root of negative 40 all over 2. Well, okay, I know because of the negative I'm going to have an I on the outside, so I'll make that a positive and put an I. And then I know that 40 is 4 times 10. So the square root of 4 is 2. So I'm going to have negative 12 plus or minus 2 square roots of 10 I all over 2. And since they're both divisible by 2, negative 12 divided by 2 is a negative 6. 2 divided by 2 is 1. You don't need to write it, but I did. And there you go. Okay. So there's your review worked out. A lot of the problems are going to be multiple choice, but you still have to be able to figure out how to get there. Okay?